Hello, everyone. My name is Matias Grignola, and welcome to my presentation on databases. So, first off, to start with a definition. So, a database is a structured set of data held in a computer, especially one that is accessible in various ways. It also has a range of how much data can be stored. So, when it comes to databases, there's levels of understanding. They are an external view, a conceptual view, and an internal, also known as a physical view. An external view, so end users see the organization of data in the database. Single databases can have multiple external views since data can be organized in many different forms depending on what is needed. A conceptual view, this unifies all the external views into compilable global views for a better understanding of how all the data is arranged within the database. Um, this level provides like I said, a synthesis for all the external views, just a compilation. And the final view is the internal or physical view, and this view of databases is concerned with performance, cost, scalability, upgradability, cybersecurity, and upkeep. So basically, this view is concerned with the gears that keep databases running on a day-to-day basis. There are also numerous kinds of databases that I'll go over. There's in-memory databases, active databases, cloud databases, data warehouses, and navigational databases. So to start off, in-memory databases, information is held in the main memory. These databases also have backups, non-volatile computer storage, which helps with security. So not on computer systems that are easily accessible. In-memory databases are faster than disk-using servers. This makes the information more readily available, and they're used when needing quick response or calculation times. Active databases, these are event-driven architectural databases which can respond to events both inside and outside of the databases. Because these can respond both inside and outside, active databases are commonly used in security, alerting, statistical computing, information gathering, and authorization. So say someone tries to hack into a database, an active database will respond to the internal hacking that's going on, and will be able to send out a notification or respond to the hacking internally. A cloud database, pretty straightforward. It resides in the cloud. Everything's backed up there. I have another YouTube video on cloud computing if you want to check that out to learn more about cloud computing. But this area of databases is the biggest expanding one currently. Many companies are moving to cloud systems as a whole. Netflix moved their whole operations onto Amazon's cloud services. Next is a navigational warehouse, and this one's more technical. It follows a hierarchical and network model that allows records or objects to be found by using and following references from other objects within service. So imagine like a spider web. Everything's connected, and you can find pathways. This is how navigational warehouses work. Next, there's database storage, which they all have, and this is the physical materialization of the data. Permanent storage of the data is done by encoding that data, which encoding allows for more security and smaller file sizes. Another big factor when it comes to databases is security. And when it comes to security, you not only protect the content, but user information and owner information as well. Ways that security can be implemented is by restricting access to certain information and restricting access to unauthorized users. And security can fall to like a user. Say you have a private server that's up to you, or a group within a company that is responsible for security, but you can also contract out a company that'll protect all your servers. Backups are really important when it comes to databases. You can a backup is a save state of um, of the internal memory of the database. This can either be partial or a complete backup. The nice thing about backups is that you can restore all this information to your computer. So you're basically going back in time and restoring um, versions of files on the computer before the time that you experienced an error or a loss of information. And backups, you can make them as frequent or as infrequent as you want, but it is usually recommended that you do them pretty frequently in the case that you work on a lot of important things. DBMS, so a DBMS is a database management system. Um, these are computer software applications that can interact with the user and the application to capture, utilize, analyze data, all those things. There are a lot of big companies that have database management systems, for instance, such as Oracle, which is the most well-known database company. And speaking of Oracle, um, so Oracle has an object relational database management system, and this means that objects are directly supported in database schemas and allow containers and lists of information, as well as like nested objects within the database. So it's a very intricate and complete form of a database. The goal of their database is the goal of their database structure rather is to bridge the gap between relational databases, all these intricate informational holding databases, and the object modeling techniques, which many language codes have, such as Java. So basically, try to bridge the gap between these large coding languages and real structured, intricate information. Oracle Server also has a server-side memory structure known as SGA, which stands for System Global Area, which holds cache information like passwords and history, things like that, and data buffers, which provide recent recent backups. Oracle also uses something called RAC, or Real Application Clusters, which uses multiple instances attached to a central storage array. This allows for quick response times and things like that. So this is all attached to the central storage of the server. So in conclusion, databases are currently how connectivity and data storage work globally. There are servers everywhere in the world and in space. There's no way around it if you plan to be efficient in the 21st century. But it's worth reminding you that these things can always be hacked, and the information is readily accessible by any connected device. So thank you very much for tuning in, and here are my sources if you would like to learn more. Thank you very much.